When it comes to performance, sometimes it's not the big, glaring topics that cause the most problems. It's the little things that, when added together, create huge headaches for your application. My name is Colt McCandless, and one of the quintessential examples of small things adding up to big problems is a feature in the Java programming language known as autoboxing. See, to the Java language, primitive types like int, bool, and float are great for matching their IEEE and hardware definitions, but this also keeps them from being used with generic collections offered by the runtime. Instead, the Java language provides object versions of these primitives, like java.lang.integer, which give you the same functionality as a primitive int, but can be used with generic collections. This is where autoboxing comes in. Autoboxing, at its core, converts from primitives to their object counterparts on your behalf so that you don't have to worry about any of those conversions in your code, which is generally pretty awesome. Take this simple for loop, for example. We can easily treat the integer object just like it were a primitive int without any extra syntax. But sadly, the hands-free nature of this functionality comes with some performance penalties. See, for each step of the integer object version of the loop, the runtime has to create a new integer object, push the primitive value into it before it can be able to be added back to the other integer object. Which means that anytime you do an autoboxing conversion, a new object allocation comes along with it. Compare this with the version using primitives that doesn't require any additional allocation overhead. This is really painful to watch since these objects are larger in size than their primitive counterparts, 16 bytes for the integer object rather than 4 for the primitive, and also require more performance overhead in order to access the underlying value, basically creating a double whammy of issues for memory and runtime performance. Now, you need to be aware that this problem doesn't just pop up with contrived examples like our little for loop here. Nope, it's present anytime you pair a generic collection with a primitive type, which is especially a problem for containers like HashMap. Basically, anytime you insert, edit, or retrieve values with this generic container while a primitive is involved, you end up boxing and unboxing values, which is the exact reason that the Android platform provides custom containers for you to use in these situations instead of HashMap. The sparse map family of containers are all designed specifically to combat the autoboxing problem, eliminating both the runtime overhead and reducing the memory footprint. Now, if you're not sure where in your code autoboxing could be causing a problem, the Android Studio tools can help you track it down. If you're using Allocation Tracker, keep a lookout for any places where you have a load of integer objects all coming from a single call site. And in Trace View, watch out for a flood of integer.valueOf calls happening for any given reason. Both of these reports are a clear sign that autoboxing is occurring. While the low-hanging fruit of performance is the easiest to fix and the most common to find, these little problems really start to add up and cause really big issues if left unchecked. Which is why you need to check out the rest of the Android Performance Patterns content to see what else is lurking in the shadows. And of course, don't forget to join our Google Plus community as well for other great tips and advice. So keep calm, profile your code, and always remember, perf matters.